Hello, my name is Muhammad Nadim Abdul Basit. Today I'm going to present my answers for biometry final test question number 3. So this is the question given to me about an undergrad student who is doing his final year thesis. He collected data from students and he is going to study about the relationship between the body and age of students. So his research question was, is the body weight determined by age? And this is the data obtained by the students. The data were taken from 10 individuals. So to correct his research questions, I came up with a new one. My research question is there any statistical linear relationship between weight and age of male UMS students? The experimental design is the weight and age were recorded from 10 UMS male students, and the data type, which are the weight and age, are both in scale data. So first of all, I tabulate all the data obtained into a table of 3 columns, which are student ID, weight, and age. And then to further investigate the relationship, I plot all the data into a scatter plot graph so we can visually see the relationship. And also the best fit line can be can be plotted after we get the coefficient relationship and the y-intercept, which I will investigate using the RStudio. And also we need to conduct ANOVA and t-test for regression coefficient. So both of these tests, the hypothesis is going to be, for the null hypothesis, the regression coefficient is equal to 0, and for the alternate hypothesis, the regression coefficient is not equal to 0. So I'm going to show you the RStudio to run this test. So first of all, we need to set a working directory using this script, and then we need to read the files with our data using this script. And then we need to do normality tests for both weight and age using this script. So for the normality test, we use Shapiro Wilk normality test, and both result came out as normal. The p-value is more than 0.0.5, so both data is considered as normal. Sorry. And then we can plot the data into a scattered plot graph by using this script. So for these two line of script are on how to put the title and to rename the label on X and Y axis. And then for the simple linear regression model as the subject, then we will run the test using this script. After that, if we only key in the subject name, it will directly give you the regression coefficient and the y-intercept. So manually you can already draw your you can manually draw your best fit line using this, because we already know the equation is y equals to mx plus c. So this is going to y, and this is going to be your c, which is the y-intercept, and this is going to be your m, which is the slope or the regression coefficient. And to plot and to draw the line on using this RStudio, we will use this script. So as I said, we need to run ANOVA test. So just simply type ANOVA and then the subject name, and the result will come out like this. As you can see, this is the degree of freedom for the regression coefficient and the residuals. And this is the F value and the P value. And the result is we we are not going to reject the null hypothesis, but it doesn't mean that there is no relationship at all between age and weight of students, but maybe the relationship is not linear. And then we can run this script to further investigate the relationship. As you can see, the coefficient, the regression coefficient and the y-intercept came out same as the when we run the SLR model, and we can conclude that the the relationship between weight and age of UMS male students is not a linear relationship. So this is the R square, which indicates that the simple linear regression model only shows 1% of variance. So to jump up into the conclusion, my conclusion is that the relationship between weight and age of UMS male students is not a linear relationship. That's all for me. Thank you.